In today's video, we're looking at the Leslie's cube. This is a thermal radiation demonstration. So the Leslie cube is a hollow cube. This one's made of copper, and the surfaces are painted or treated in different ways. So there's one side that is shiny copper, one side is glossy white, one side is dull copper, and one side is matte black. And you can see we've got it mounted on a turntable. There's just some bits of plywood with Lazy Susan bearings between, so we can turn it around, keeping it the same distance from sensors without touching the cube, because it does get very hot once we fill it with hot water. I've got diagonals marked on the plywood, so we can line it up by getting the corners exactly on the diagonals. I'm going to fill it with hot water. So I've just boiled a kettle. So it's about 3/4 full. I'm going to put the lid on, and now we'll take the camera around the other side so we can see the effect of the sensors. I'm trying a solid state thermopile connected to a meter on millivolts, and we have a thermal imaging camera. So the reading on the millivolts on the white surface is 6.9 or 7, 6.9 to 7 millivolts. Temperature reading using the thermal imaging camera is 94. We turn it to the shiny copper side. The temperature reading on the thermal imaging camera is down to 26.4, and the actual temperature reading that it's showing is a bit confusing. It's the thermal energy being given off, and it's doing an estimate of the temperature of the surface dependent on how much it's radiated. So it's not a true temperature reading, but it is a measure of infrared radiation. Now, thermopile has gone down to 0.1, 0.1, 0.2, it just flicked up to. So now we'll go to the black surface. We're getting 7.1, so just slightly higher reading. 91 degrees centigrade on the thermal imaging camera. Dull copper down to 3.5 millivolts, 57, 6.5, somewhere around there on the thermal imaging camera. You can see it varies quite a bit with how tarnished the surface is. Let's go back to the white, and although we're getting a lower temperature on or reading on the thermopile, the actual reading on the thermal imaging camera shows it at a higher temperature than the black side. So it often doesn't give the expected results, and often it's quoted as being because we are measuring the infrared radiation being given off and comparing it against the radiation being given off or reflected in the visible spectrum. And also, if you look it up online, they talk about the composition of paints are designed to have lots of things like titanium dioxide that gives good coverage to make it opaque, and this affects the thermal radiation that it gives off, and paints tend to give off more thermal radiation. As you can see, even the dull surface appears to be giving off a lot less radiation than a shiny white surface. Also, you do get reflections on surfaces. You can see, if I turn round to the shiny surface, you can see the camera reflected, and you can see my hand reflected in that. So it is quite a difficult demonstration to do, and the solid state thermopile seems to be quite a good way of doing it, because we are getting a higher reading on the black than with the white, which is we often don't get using temperatures from an infrared camera or an infrared thermometer. Some people use the handheld type infrared thermometers. Sorry about the background noise. We're having new fire alarms fitted today,